Hello and welcome to my lesson 6.4 on Pascal's triangle. So we have this mapping question, and we've already seen one like this in the previous topics, but we're going to solve it two different ways. So first of all, we're going to solve it like we saw before in the permutations repetition lesson, which is to say, how many times, if it can only go forward from start to finish, that means it can't go up or left. So it has to go to the right. And how many times does it have to go to the right? At some point in the question, it has to go to the right 4 times. So I make this into a letter question, go R, 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 R. And then I say it has to go down 3 times. And that has to happen at some point in the question. D, D, D. So this is how I set up these questions. This is now a word problem because now I can just look at these ones and say, oh, there's a total of 7 factorial options. And then I can divide by the repetition. So 3 factorial, 4 factorial. So in total, that'll be 7 times 6 times 5 times 4 factorial over 3 factorial, 4 factorial. The nice thing is 4 cancels with 4 factorial, 3 cancels with the number 6, and so we are left with 35. So that means there's 35 different options to get from there to there. And this is how, honestly, I still recommend that you do these questions, but I'm going to show you a new way of doing these questions, which is interesting and fine, and if you like this way, you can use it, but it's going to connect with the next lesson more so. So even if you don't use it for one of these mapping questions, I promise it will become useful shortly. So what we're going to do is we're going to look at every position on the grid and ask how many options are there to get to that position. So if we're going here, well, the only way to get there is this one single pathway. So I'm going to put a 1 there. And then the only way to get to here is this one single pathway. So there's still a 1. And the only way to get to here is one single pathway. You get the picture. Those are 1, 1, 1, 1, 1. But if we want to get to this position, we could go this way or this way. Notice I used the word or, which means we add. So we add the 2 pathways on either side. So there's one option to get there, one option to get there. So that means there's 2 options to get to that corner. So same sort of thing here. To get to this spot, we could go this way, or this way, or this way. Notice that we went through this position twice. So all we do is we add the 2 and the 1, and we can get the 3 that's going to go here. And hopefully you can start to see the pattern. We're just going to add the 2 numbers that are beside it, and that pattern can kind of just continue. This one here is a little bit different now. It's 3 plus 3 is 6. 6 plus 4 is 10. 10. This is 15. This is 20. And this is 35. Okay, so we still get to the same number of 35, which is good. It better be the same number. But what's interesting is we can turn this rectangle on its side. So I'm just going to go ahead and fill out these numbers again. But what I'm going to do is I'm going to continue this pattern down. And the reason why I'm doing this is because now you'll be able to see a little bit further. Here we get the 5. Ooh, it matches the 5 over there. This one gets us a 6. This one gets us a 15. Oh, that matches the 15 over there. This gets us a 6. Oh, that matches the 6 over there. Okay, let's go down actually one further position. So it's obviously still a 1 and a 1 here, but this is going to be a 7. This is going to be a 7. Oh, those match. This is going to be a 21. This is going to be a 21. Ooh, this is a 35, and this is a 35. So what we can see, hopefully, is that the triangle is symmetrical. This side of the triangle and this side of the triangle are identical. They are symmetrical with each other. And then obviously down the middle, there's, unique numbers there, but they're symmetrical on either side. And this is a useful tool, and this is what we call Pascal's triangle. And so what we'll notice is it's actually a bit of a pattern. So what we're going to see here is that combinations from the previous lesson are also symmetrical, right? If you remember from the previous lesson, we said, and actually these options down here are a little bit easier to think about. Let's say there are 5 different types of fruit, okay? Let's say there's an apple, a banana, a orange, a berry, a pear, 1, 2, 3, 4, 5. Okay, let's actually put a strawberry. Let's put a strawberry because I want a different letter. Okay, so we've got 5 different types of fruit, okay? And in these fruit, we're going to choose 2 of them. Well, if I choose 2 of the fruit, the apple and the banana, well, I'm automatically not choosing the other 3 fruit. So one way you can think about it is 5 choose 2. The other way you can think about it is 5 choose 3. And at the end of the day, they should be the same number. And if we take a look at these examples, they are the same number. Both of these are going to be 1. Both of these are going to be 5. And interestingly, both of these are 10. What do these match with? Well, these are matching with, and maybe I'll just circle all 3 of them. They're matching with one of our rows here. So we have 1, 5, 10, 10, 5, 1. That matches with a combination statement. So that means every single one of these rows, technically this is like 0 combination 0, but the next one is 1 combination something. The next one is 2 combination something. The next one is 3 combination something, 4 combination something, and the one we just did, 5 combination something, 6 combination something, and 7 combination something. You can continue this pattern on forever and ever, but my point is that each of the items going down the row is whatever combination that it is. So if you look here at, maybe I'll try to use a different color. I'm starting to make it a little bit too messy here. Maybe we'll use black. These ones down here, this one has combination of 0, like the R value. The R value is 0. This is an R value of 1, 2, 3, 4, 5, 6, 7. And then that's our last row, what it looks like. But as you go up, each one changes. So if you take a look here, you can see that pattern taking place. But again, notice that this and this match, right? It's symmetrical. Or if you pick any 2 ones in the middle, this and this match. They're symmetrical. This match. And this is Pascal's triangle. So I hope that this helps you better understand Pascal's triangle, as we're going to be using it in the next lesson, binomial theorem. Hope the video helped, and good luck.